All right, so what we're going to do with this is, yeah, you can go away now. Okay. So what we're going to do with this is, when it says test an appropriate hypothesis and state your conclusion, on an AP exam, it's unlikely, well, it may say that, but more likely what it is going to say is there evidence that it is better to study while listening to Mozart than to rap music? And whenever it asks for evidence of something, it's asking you to run a hypothesis test. Since we have two different samples here, so we're looking just at the rap music versus Mozart. So we're not looking at the no music group. So we're going to start with so this is number 36. We're going to start with our hypothesis. And our null hypothesis is generally going to be that there is no difference between the two groups. So the hypothesis that I'm making is about the mean for the two groups. So mu is my population mean. So since the mean for the rap group was slightly larger than the Mozart group, I'm going to put that one first. So the mean for R minus the mean for M equals 0. The other way that you can write that, and I'm going to zoom in a little bit on that because that's kind of small. You can see how funky my R looks. So the mean for R minus the mean for Mozart equals 0. The other way you can write that is the mean for the rap group equals the mean for the Mozart group. Either one of those is fine. The alternative hypothesis depends on how it's being asked. So, does it appear that it is better to study while listening to Mozart than to rap music? So that is appearing to be a one-sided test, and now that they put it that way, I'm going to swap those because of the way that they asked. So the alternative is that the mean for Mozart is greater than the mean for rap, or, and I should have put those one under the other, but just because I'm screwing with you guys, the mean for Mozart minus the mean for the rap group would be greater than 0. So if I was going to write it this way, I would use this as my alternative. If I was going to use it this way, I would write this for my alternative. It doesn't matter that much, but it's a little bit more sensible that way. When I'm checking these, when I'm checking the conditions for that, so that's my next section, this in and of itself is going to be one part of that hypothesis test. That's worth 1 point out of your 4. Make sure that you're making hypotheses about mu and not about y bar. You know what y bar is from your sample, so you don't want to make hypotheses about that. So in our conditions, it says that the 62 people were randomly assigned. So we know both groups were randomly assigned. That takes care of our randomization condition. That also takes care of our independent groups. If the samples were randomly assigned, it's very unlikely that they would affect each other. So both groups were randomly assigned and independent. As we've mentioned before, as we talked about last class, it's not necessary to check the 10% condition unless we have a very, very small population or very very large sample. In this case, we do not, so we don't need to check the 10% condition. And then the final thing we need to check is the nearly normal condition, and we really don't have anything to check that with, so the main thing we're looking at is our sample size. This is so this is close to 30. The Mozart group is a little bit small, but it's more than 15, so that's enough to go on. So both groups have an N of greater than 15. So we can use the central limit theorem. And by the way, in the future, it's okay to abbreviate that as CLT. In the stats world, they know what you're referring to when you say that. So we can use the central limit theorem to run a two-sample t-test. And if you want to set an alpha level at this point, just so you know what you want to end up with, you can go ahead and add that with alpha equals 0.05. I wouldn't do anything other than 0.05 if you're setting an alpha level for yourself. All right, so those are our conditions: randomization, independent groups, nearly normal. That's what we checked with the sample size, since we don't have any information about what those histograms would look like. And then state what test you're using. So in our mechanics portion, so let's scoot that up, I'm going to go ahead and write these out. So our Mozart group had an N of 29, a mean of 10, no, sorry, the Mozart group had a N of 20, had a mean of 10, and that mean is an average of 10 objects remembered. And then, okay, I'm screwing with you guys left and right. That's not mu. Why is that one not mu? Any ideas? So because that is our sample mean, that's y bar of 10, and then a standard deviation of 3.19. And our wrap group had an N of 29, a y bar of 10.72, and a standard deviation of 3.99. So with the two-sample t-test, you're not really doing any mechanics. So take a moment and grab a calculator if you don't have one already. So because we cannot easily figure out the degrees of freedom when it comes to a two-sample t-test, we do everything on the calculator, and that's perfectly acceptable when it comes to the AP exam. You just need to write that your information is coming from the calculator. Whether you can do that on every test, I still haven't gotten a solid answer for, but I do know for two-sample t-tests it's acceptable. So go to the stat menu. And sorry about the glare there. Over to test. And you're going to do the two-sample t-test. And make sure when you do this, you look carefully at them, because they do all look a lot alike, or the ones next to each other look a lot alike. The two-sample t-test, in this case we have the statistics. In some cases we have lists of data that we put into our list, then we would use the data. But because we just have the means and standard deviation, we're going to use the stats, so make sure that's highlighted. Our X bar, or Y bar, from group 1, the Mozart group, is 10. Standard deviation is 3.19. Our N is 20. The y bar or x bar from the wrap group is 10.72, standard deviation of 3.99, and an n of 29. Our hypothesis, we have three different hypotheses here. This is that they are not equal. That is that group 2 is greater than group 1, so the wrap group is greater than the Mozart group. And the alternative here is that the Mozart group is greater than the wrap group. And that was what it was asking. Does it appear that it's better to study while listening to Mozart than to rap? So that is the one that we're going with. So one of the things is that it's important to just make sure you know which is your group 1 and which is your group 2. In the calculator here, we have the Mozart group as group 1 and the rap group as group 2. Any questions on that? So we do not pool for this. I'll discuss that further, but generally speaking, for the purposes of this class, don't pool for a 2-sample t-test. And then you calculate. So what I have here, I'm going to scooch that over, try to get it out of the glare a little bit, and then write down what I end up with. I have a t of -0.7, p-value of 0.756, degrees of freedom at 45.88, and then the rest of this information on here is just what you already put in, the means, the standard deviations, and the ends. So the other thing we need to put here is, this is from calculator, from technology, something along those lines, so you don't just have numbers there that there's no explanation as to why they're there. So what I have written with the summation of all of this part, that's not even necessary in your mechanics part. This is really all you need. So one of the things that I said in the slides, or that I'll probably fix, but it was in the slides, is that you should go back and show your work if you have time. Honestly, that probably just leaves you more space or opportunity to make a silly mistake and put in the wrong numbers in the wrong place. I would just put this. I don't think there's any advantage to writing anything more than your t statistic, your p-value, and your degrees of freedom. So that's that. And this is not a terribly surprising p-value, because what we're seeing in our numbers over here is that the mean for the rap group was actually slightly higher than the Mozart group, though with a slightly larger standard deviation. So based on this p-value, what would we do about the null hypothesis? Is that a high or low p-value? That is a high p-value. So based on the high p-value, or on the fact that it's greater than 0.05, because we did set that alpha level, would I reject or fail to reject? Fail to reject. So if I fail to reject the null hypothesis, do I have evidence of a difference, or do I lack evidence of a difference? I lack evidence. So we do not, or I do not, or however you want to say that, or there is not evidence. I do not have evidence of a difference. Actually, I'll address specifically the question that they asked. I do not have evidence that listening to Mozart is better than listening to rap while studying. So, two things in that conclusion. Connect your decision to your p-value, whether you mention that it's a high or a low p-value, whether you mention that it's greater than the alpha level or less than the alpha level. Make sure you link your p-value in some clear manner to your decision to reject or fail to reject the null hypothesis. And then follow that up with your answer in context. Do you have evidence or do you not? If you fail to reject the null hypothesis, you do not have evidence of a difference between the two groups, or that, more specifically in this case, that it's better to listen to Mozart than rap music. If you reject the null hypothesis, you do have evidence. So, that is the two-sample t-test. Because our mechanics section is so short, there's not a lot to it. We are going to follow that up with part B, which is a confidence interval. With the confidence interval, conditions have been checked. So we'll run a 90%. Sorry, let me restate. So I'll run a two-sample T interval at 90% confidence. It's a fairly redundant and kind of unnecessary statement, but they do want you often to say what you're doing. The two-sample t-test, the two-sample t-interval. Once we have, we're starting to collect how many tests we have, but once we have more, that becomes more important. This is back to the calculator. So we go to the test menu again, so stat, over to test, two-sample t-interval. Again, we have the statistics. These are already in there for us for the interval. That's convenient. So our group 1 was our Mozart group. Standard deviation of 3.19, N of 20. Group 2 had a mean of, the rap group had a mean of 10.72, 3.99, 29. Confidence level we want to change to 90%. Thank you. So it was just brought to my attention that, and I just said that for the video, that we have a different question on this one. So this was asking about Mozart and no music at all. So we need to change that. So we'll do the first group as the Mozart group, and then the second group, no music at all, that was 12.77, standard deviation of 4.73, and a count of, or an N of 13. Now we're at 90% confidence. We do not pool and calculate. So our interval once again from the calculator is negative 5.0 0.351 to negative 0.1886. And 19.09 degrees of freedom. Okay. So the interpretation with the confidence interval can be the trickiest part. This one does not include 0 in our confidence interval, so what does that indicate about whether there is a significant difference between those two, between the Mozart and the no music group? Yeah, there does appear to be a significant difference. If we had run a confidence interval on the rap and Mozart group, that interval would have included 0 because we did not find a significant difference there. However, so we did the Mozart group minus the no music group on this one, and we ended up with a negative. So what are these numbers actually? That's the mean what? What are they keeping track of? The difference in what specifically? I didn't quite hear you. Yeah, the amount of objects, the mean number of objects remembered. So what this indicates is that the Mozart group remembered an average of between negative 5.35, sorry, let me restate that. Not the Mozart group had, because we know those averages, but what we would expect to see in the future, or what we expect the true mean to actually be, and I'll write this down better in just a minute, is the Mozart group is between negative, remembers between 5.35 and 0.1886 objects fewer on average than the no music group. So let's write that out. So I am 90% confident, pardon me, that the Mozart group, wow, sorry, that people listening to Mozart would remember an average of 5.35 and 0.1886, I don't have to write that whole decimal, but objects fewer than those listening to no music. An average of, I would change 2, so you can put between in front of there as well. So it would remember an average of 5.35 to 1.1886 objects fewer than those listening to no music. Yeah.
Checking the neuronormal condition different for this one besides the no music.
That's a very good question. I skipped over that. So the question there, for those of you who didn't hear it, was checking the nearly normal condition going to be different for the no music group because our sample size there is only 13, and that could cause an issue. because it's less than 15 and we don't know if it's highly skewed or anything like that, the most we can say is that we don't have this information. We should be cautious of these results because the sample size is so small. Other questions on that? Mm-hmm.